Welcome back. Today we will be talking about the direct inverse and joint variations. These words, they might seem to be a little bit different, but you know about the direct variation very well because direct variation, the simple direct variation we can think about is y is equal to mx plus b form, where b is not equal to 0 and y-intercept is technically a non-zero. When the y-intercept is a 0, then I can tweak this y is equal to mxb into y is equal to kx form. Understand, with the direct variation, it is always the product, right? With the x and the constant. So y is equal to kx is where when the y-intercept is 0 and k is nothing but constant of proportionality. So remember, direct variation, it is a product, and we can, how to pronounce it or how to say about the direct variation in a more mathematical way. We can say y varies directly as x. The another way to say is y is directly proportional to x. So if in any question it says directly proportional, so directly proportional implies we are multiplying the constant with the x term. It is a product, right? Keeping that thing in mind, let's try this word problem. So if you read the word problem, it says in the first line that the state income tax is directly proportional and that they have given the state income tax deduction and the monthly income as well. They want you to calculate the gross income. Remember, when they are talking about the gross income, that means it is not the net income. Net income is after the taxes, right? So because it is directly proportional, we are multiplying the constant with the variable x. Let's define some variables. So let's say the state income tax be y, and rate, because it will remain constant, it will not vary with the income. So the rate is constant, and that is why it is k. And gross income that I need to calculate is nothing but x, right? So if I multiply the gross income with the rate, I will get the state income tax. So because it's directly proportional, we are multiplying the constant with the x. Let's plug in the values. So state income is given as 46.04 or $46.05. And the monthly income, the gross monthly income is given as 1500. So if I plug everything in y is equal to kx form, I will be able to get the value of k. So value of k, when you plug it in the calculator, it will be 0.0307, right? Which is nothing but 3.07%. And I can rewrite y is equal to kx term in this particular format. This is all about direct variation. Some questions might be a little bit tricky, but always look for whether they are asking for direct variation or direct proportionality or inverse. And because it's a word problem, always write the word sentence in the last. Right? So it will be 3.07% of the gross income. Now, that being said, now we can also talk about the direct variation when we have the nth power. So let me write it down. So direct variation of nth power, because in y is equal to kx form, the x has the power of 1. What will happen when we have a power more than 1? So the easy example is area of a circle. In area of a circle, we have pi r squared. So x is nothing but r in this case, and k is nothing but pi. So we have the power higher than 1. So with that, let's take one more example. Another word problem. So if you read the first sentence in the word problem, it says it's directly proportional. That means y is equal to kx. Now what if x is having a power or not? That is defined because it says directly proportional to the square of the time. That means x is squared. So basically what is happening, the ball is rolling down in the inclined plane. So we can say time is nothing but t in seconds, distance is in feet, and because it's a square of times, we can say d is equal to kt squared, because remember t in this case is nothing but the variable x. So it will be kt squared. Now let's solve the first problem. It says write an equation relating the distance traveled to the time. So we have t is equal to 1 in this case, and the distance is 8 feet because it says during the first second the ball rolls 8 feet. Now we will write our equation. D is equal to kt squared, and let's plug everything back. D is 8, t is 1, that will give you k as 8. So I can write it down in an equation. We can say d is equal to 8 times t squared. Let's talk about question number B. It says what will happen after first 3 seconds. That means we are taking when t is equal to 3. We already got the equation in A. So let's plug the value of t as 3 and we will get our lovely answer, which is nothing but 72 feet. Right? So we are looking for keywords. In the word problems, always underline or highlight the keywords so that we know what we are looking for. Directly proportional is our first clue. Square of the time is our second clue, that is, it is for the nth power. Right? Now let's talk about the inverse variation. So in the direct variation, we talked about the product, right? So if we follow the same pattern, the inverse variation is nothing but in the quotient format. What it means that y will vary inversely as x, or we can say inversely proportional to x. So how should we write the equation? It is the opposite of the direct, right? So the direct was the product, so it will be the quotient format, which is p over q format. So we will say y is equal to k over x. So x will be in the denominator, k will remain in the numerator. So again, a clue, inverse is quotient format, direct is the product format. Okay. Now let's discuss few problems. So we have another word problem. So if you read the word problem carefully, in the first line it says varies inversely. That is my clue. My clue is it should be in the quotient format, and whenever it is in the quotient format, we are looking for y is equal to kx term. But we need to define some variables because the product is given and the price is given. So I can write the product varies inversely as the price of the product. So product can be taken as y and the price can be taken as p. You can interchange the product, you can interchange or use the different variables if you want. So I will tell you how, if you change the variable, how the things will go. And we can say demand is nothing but the x, or you can also say the demand is, you can assign the variable demand as p. We will do it in different way. And the price of the product is given as 6.25, and at that time the demand was 400 units. Now they want you to calculate the demand. What will be the demand when the price will be 5.75? So I can say y is equal to k over p, or p is nothing but my demand, right? So the demand was 400, but I need to calculate. Demand was the final product. That means the 400 was the final output that we gave. I need to calculate the value of k first, the constant. To calculate the k first, we can say 400, which is the final output. So we have y is equal to kp again. So p will take 6.25, and I need to calculate the constant. So we can interchange. We can say the product is x and the demand is y. So whatever works for you, it is just the playing around with the variable, but the concept is same, that y is equal to k over p. So I can plug the values as 400 is equal to k over 6.25. Now I have put x is equal to 400. You can put y is equal to 400 if you want to match with the y is equal to kp format. So the constant will be 2500. Now I know the constant to be 2500. I know the price that they want to sell at, which is 5.75. I don't know the final output. So the final output, that is y, we can calculate with this, because the constant, which is 2500, divided by the price that they are asking for. If you plug it in your calculator, you should get 435 units. And it's a word problem, so we need to write the word sentence as well. Yes, so you can interchange demand and the product variable if you want to just go with the same concept of y is equal to k over p or k over x, right? But the final output will be the same. So we can say the demand is 435 unit when the price is $5.75. Right. Okay. So this was all about the inverse variation. There is another thing in this chapter that is called the joint variation. So joint variation happens when we are talking about more than three variables or more than two variables actually, because we have a constant and the two variables are there. So the simple example is a simple interest, because in simple interest we have PRT, rate, principal, and time. So for example, let's take one example where the principal amount is 5,000 and the interest that you are getting, the simple interest that you are getting, is $43.75 in 3 months. Now when we are talking about 3 months, we are talking about 3 over 12, time in 3 over 12, because out of 12 months, we want to consider only 3 months, because in 3 months we are earning this interest. And the rate, which I don't know. So there is some interest we are earning, which is $43.75 at a rate which is unknown on the principal. So I is equal to PRT. Interest is 43.75. I know the principal, but I don't know the rate. And the time is 3 over 12. If you plug it in the calculator or do by your hand, you should get rate as 0.035, which is nothing but 3.5%. And I can rewrite my simple interest equation again as 0.035 PT, right? So 0.035 is the constant, and which is K, and then we have P and T. So this is called the joint variation. In the earlier case, we used to have K times X or K over X, only one variable X, right? In this case, we have more than one. So K is the constant, and then we have X and Y. So how to read it or how to understand it? So Z varies jointly as X and Y, and Z is jointly proportional to x and y. So that's it. This is pretty much about the direct, inverse, and joint proportion. Thank you for watching, and I will